Hi there. I just wanted to go through for this week a few of the water inventory materials that I'm expecting that you're finding. Um, I want to go through some of the things I've written down and give some example materials for some different places. And so um, this is, I will also be going through your folders individually, but when I checked on Monday, there were quite a few folders with nothing in them, so I thought this would be helpful in the meantime. Although I'll be having another look at those today and Friday. So here we go. Here's some water inventory materials that you should be finding. So the outline that I put on that spreadsheet was basically the one I'm going to follow. Some drinking water materials, what there is and how to read them. Oh, I realize I haven't done much surface water, but there's the example in surface water from the water module, where to find the status and source of impairments in your community as a starting point. We can find your wastewater treatment status on the EPA website, and how to have a look at stormwater issues. So I want to start with the drinking water quality reports from the municipal utilities. These are very useful documents. So your municipal utility should have these. Most of them have them posted on the website. And so I'm going to go through an example of that, where to find the report and how to read it. So I thought I would, again, just for basic information about your drinking water, how a drinking water system works, how you find these reports, you can go ahead and use the site at epa.gov. That's for groundwater and drinking water. Give some basic information about these reports. But I wanted to use an example. This is beautiful North Platte, Nebraska. A very detailed topographic map here from the city website. But you can see that the city is located in between the North Platte River and the South Platte River. So fairly low-lying area, right close to rivers. So we go to the city website, and here are some of the annual water quality reports. So these are produced in, judging by the last one, in about April of each year, and so that's how come the 2018 report isn't up yet. So we'll have a look at the 2017 report. So I just downloaded this. So it tells you what the source of the water is. So I guess I'll use my pointer here. Whoops. Tells you that the source, I'm not going to be able to use my pointer. So upper left, the source of water used by the city of North Platte is groundwater. And it also has a statement about source water assessment and protection and where you get that information. So the state, it says Nebraska Department of Environmental Quality has completed a source water assessment, including a wellhead protection area map and potential contaminant source inventory. So that's if this report raises questions for you, which this one does, you could look further into that. So overall, what you have on the second page of this report is a set of data, and if I just go ahead one, the first page has a guide to all those acronyms. For example, MCL is maximum contaminant level. the highest level allowed in drinking water, and then a maximum contaminant level goal, the level of a contaminant below which there's no known or expected risk to health. So maximum contaminant level is a level that's set depending on treatment technology, whereas the more health-related one is the maximum contaminant level goal. Then you have an action level, the concentration of contaminant, which if it's exceeded, triggers treatment or other requirements. So you have to then take steps to ensure that public safety is protected to a certain level. So let's go back and have a look at our contaminants. So remember, this is groundwater. So the first kind of surprising result on this is that there were 2 samples tested positive for coliform. So coliform, that's fecal coliform, but it's not necessarily human fecal coliform. It can be raccoons or cows or anything, but it's an indicator of bacterial contamination of a water source. So that's interesting for groundwater, because groundwater is not normally contaminated by coliform, because it's the poop just doesn't make it that far. So that means that when you have a coliform contamination of a groundwater, that means it's fairly shallow groundwater. So it's not a lot of samples testing positive. But it does indicate surface vulnerability of the groundwater. And so the other measures of that you can see there's surface vulnerability in this groundwater is if you go down to the regulated contaminants. I just want to draw your attention to the nitrate. So if you look at that, there on one day in 2017, there was a value of 6.59, which they record the highest value in the period. They give you the range in the sample, and it's in the unit of parts per million. There's a maximum contaminant level and a maximum contaminant level goal, both of 10 parts per million. So those are health-based standards above which you start to see health effects, particularly in babies and vulnerable populations from nitrate or nitrate. So if you look at the likely source of that contamination, runoff from fertilizer use, leaching from septic tanks, sewage, and erosion of natural deposits. So given that you have a coliform contamination and you have what's probably a runoff kind of contaminant, you've got 2 signs that the groundwater is vulnerable to surface influences. And you also have that next one down the list, tetrachloroethylene. That is discharge from factories and dry cleaners. So you have some level, and again, this is very low, it's in parts per billion, but it is 0.743 parts per billion of a dry cleaning fluid. Now here you start to see the difference between the maximum contaminant load and the maximum contaminant load goal. The health-based standard for that is the maximum contaminant load goal, 0. You don't want to be drinking any dry cleaning fluid. But the maximum contaminant load based on what treatments, once you have that in the water, what treatment technology is available is 5 parts per billion. So generally, you try to keep the dry cleaning fluid out of your groundwater by protecting the aquifer recharge area. But in this, since it's very likely groundwater influenced, basically kind of underground river water, it's pretty difficult to do that. So you have a level of dry cleaning fluid that's above your health-related goal, but below the treatment threshold. You also have a level of uranium, which is nice, wholesome, naturally occurring uranium. You have a couple of contaminants in here that are possibly natural, possibly runoff related. The arsenic rates in parts per billion are above health standard, below treatment standard, and the uranium is above health standard and below treatment standard. So if I lived in North Platte, I would be using a level of filtration on my household water. The other one that's that is a higher, what I'd call a higher health risk contaminant, is the lead. So over the monitoring period of 2014 to 2016, the higher level content of lead, 90th percentile, was 5.77 parts per billion. The action level on that is 15. So why are we calling that an action level rather than a maximum contaminant load or goal? Well, there is no healthy level of lead in drinking water, and particularly babies and young children are vulnerable to lead in a blood-brain interaction. So there's no healthy level, but it can be a naturally occurring thing. It's more likely from pipes, but in this case, to me it would be problematic if I had small children on this system. So there's a few interesting contaminant levels. None are above action level or treatment standard, which is what you expect in a municipal water report. There are a couple of notes at the bottom. The notes are primarily about the arsenic levels. I don't know why there aren't any notes about the lead levels, because lead is in a similar situation. So it says at the bottom, while your drinking water meets EPA standard for arsenic, it does contain low levels of arsenic. EPA standard balances the current understanding of the health effects against the costs of removing arsenic from drinking water. So it's a health cost balancing in there. So it talks about what the health effects of arsenic are. So lead and arsenic are both like that. They're both, lead is actually more documented to cause issues particularly in infants and small children at quite low levels of contamination. So this is how you read one of these things. It's important to read the likely source of contamination, because we do have some fairly serious, there can be some fairly serious contaminant sources that are from natural sources. So, in truth, naturally occurring uranium, lead, and arsenic aren't really any better for you than introduced uranium. You have to watch out for those naturally occurring contaminants. It is interesting. There's a fair number of sort of radioactive contaminants in this water, which I guess is not uncommon in the depending on what the groundwater rock is that it's flowing by. So what do you need to read these? You need to read the, is there anything over action level? Is there anything that's over maximum contaminant level goal? Because remember, that's the health-based standard. So for example, the chromium at 100, if the maximum contaminant level goal is 100, a chromium of 1 part per billion is probably not a problem. Whereas the tetrachloroethylene, the arsenic, and the lead are probably not they're not going to have good health effects. Their health effects are not going to be 0. But these all meet the kind of balancing of cost and practicalities and health-based standards that there are for drinking water. So that's how you read one of these reports. And so what would I note from this? For my inventory, I would note that the groundwater source is vulnerable to surface pollution. And I conclude that from the coliform, the nitrate and nitrite levels, which are on the high side, and the tetrachloroethylene, which is just a problematic contaminant. So that was the city of North Platte. And then I would want, do you see any other indications that the groundwater is vulnerable? You might want to think about that based on your knowledge of the local geology and the other things that you turn up. One of the things I would want to know is where is there a defined aquifer recharge area? And so I would dig in more to the source water assessment report from the Department of Environmental Quality in this case. Like, I would go after that one. For many of these water quality reports, especially with a groundwater source, you won't see any of those levels of contamination, and you'll go, okay, well, that seems fairly solid. So the other part of that one report gives you the source. Let me just go back. It gives you the source and the quality, and you can look around for the treatment method. They will, in that, I would bet over 25 cents that that system will chlorinate the water, partly residual chlorination just for the water running through the pipes to the households, and partly because they do have some coliform readings occasionally. And depending on how big the utility is, some of the larger utilities will keep an eye on that and chlorinate more when there's higher levels of either recorded coliform or what's called turbidity, if there's suspended solids or something like that in the water that might prevent them from actually getting a coliform reading, then they'll chlorinate at higher levels seasonally. So you can access the water, you can call the water utility and ask them about their treatment process. There are other treatment methods than chlorination, although most health departments are very fond of what's called residual chlorination for while the water is running through the pipes. So then the other piece of that was, is there anything, the other piece of that part of the inventory was, what can you see for water conservation. And so I thought I'd just use the example of the Denver area. One of the groups has chosen to work on Denver, and they have the most information, I would say. Well, the California groups might also have this level of kind of layers of water conservation information in their case, whereas some of the other groups won't have this many layers and will likely just have the municipal layer. So I thought I'd start with the complicated example. So first, just kind of identify for the inventory level, just kind of identify and describe what the levels are of water conservation kinds of activities. So first of all, there's just an understanding that there's an interstate agreement called the Colorado River Compact, which is a law. The Colorado River Compact, written in 1992, is an interstate agreement. And so it does, the states that are party to the agreement do work together on the agreement, but it basically assigns a supply of water to upstream and downstream states. Excuse me, in that the upstream states are required to release a certain amount to the downstream states. So at the state level, there's a Colorado Water Conservation Board, which has a whole set of activities and undertakings. So there's a very high level of water management in the state of Colorado. You can see just the legal, there's the interstate, there's more than one interstate compact, one of them involving the South Platte River, actually. And so there's a Colorado Water Plan, there's measures for water efficiency, there's drought and flood and water supply planning. So for your inventory, you want to make sure that you understand what supports and sort of guidance is available at the state level. So I just sort of flew through some of these. For example, there's supports for local drought planning. Each local jurisdiction in Colorado is basically encouraged to undertake drought planning. How will each local jurisdiction deal with drought? And so there's supports for that, and there's financial assistance, and how will you mitigate the effects of drought on your local jurisdiction? There's also, Colorado has had several recent severe floods in various parts of the state, and certainly the state participates in the National Flood Insurance Program, which is one of the links I provided in the inventory, so that you can see how those flood maps interact with flood insurance programs. But basically, Colorado State helps to, it has this organization, the Water Conservation Board, is the one that helps to implement the National Flood Insurance Program and does the flood response in the state. One of the more interesting aspects of this kind of state is that the state does water supply planning. So in part, this is in a response to recent droughts, and in part, it's a response to being a participant in that interstate compact. And so that's different. It's going to be different. Not all states are going to have this kind of level of water supply planning, but this also acts as a resource for municipalities. So when you get even to a large municipality like the city of Denver, they're going to be able to benefit from some of that state knowledge and assistance. But if we just open up the Denver Water Utility webpage, you can see it's quite different from the city of, I mean, obviously it's different from the city of North Platte. It's a much bigger city. But one of the things you see right front page is elements of household water conservation. So they're going to have conservation rates, and they have, in some cases, and conservation programs in the city of Denver. So again, the city water utility is a great source in this case for water conservation measures. Whereas in some of the other jurisdictions where water supply hasn't yet been an issue, the water conservation programs and efforts might not be so visible. So in terms of the statewide water supply planning, water shortages are predicted basically as a function of population growth, sort of an assumption about how much water each household is going to use, as well as climate change. You have drought and you have loss of glaciation, which means that the water that is there is not going to be flowing smoothly out of the mountains over the time of the melt. So you're going to have the water rushing by in what's called freshet in the spring. This jurisdiction, like many others in the Mountain West, is going to be trying to use a more reservoir system, more storage, and more conservation. Water conservation measures are going to be front and center, although there can be a lot more household cultural water conservation done. And of course, one of the major functions in terms of water conservation is actually how large the house and lot are that the household has. So I'm not sure in the case of Denver whether water conservation as a concept yet includes the possibility that people could live in smaller houses or not have lawns, or not water, have brown lawns. I have noticed that Colorado parks are not watered like English to imitate English gardens like so many parks are, but still it's interesting to see how much we can adapt to this changing natural environment. I did notice as I was flying through there that there's some what I would call green infrastructure measures being put in place along with the sort of more gray infrastructure engineering of reservoirs. There's also green infrastructure measures to ensure that, for example, wetlands, to basically slow some of that evaporation so that agreed on volume can be delivered downstream. And we've already seen that there's state-supported municipal efforts in this state. So you would hope to see that kind of activity in the other Colorado Interstate Water Compact states or other drought-affected states. So in terms of wastewater treatment, which was on the inventory sheet, again, we have these difference in scale of places that the different groups are working on. And what I put on the spreadsheet was what kind of wastewater quality is the city or town putting into receiving waters. So for larger places, the simplest way to answer that is to check on the EPA website whether or not the wastewater system is in compliance with, I use the acronym, the National Pollutant Discharge Elimination System permit. It is a permit under the Clean Water Act. Wastewater systems are a point source, so they would have a point source permit. So is that wastewater treatment system in compliance with that permit? That tells you at least if the city is meeting federal requirements for its wastewater treatment. So for smaller places, it might be more interesting to have a look at that, particularly if the system is not in compliance. There are some smaller places where there's still just very minimal level of sewage treatments, or lagoons are used or something along those lines. And just look into whether the city or the town has looked at costs of upgrades, and how they investigated some more of the ecological sewage treatment kind of investments as an option. It is possible to use a modified wetland to treat wastewater effluent at the scale of some smaller places at any rate. So what I thought I'd give you an example of is actually Kansas City, which Liz is working on. So again, I would suggest that if you're new to this, you want to just start with some definition of terms and make sure you know what NPDES is, those kinds of things. And so the EPA website is, again, a good start place. And it defines some of the larger places. I think I put on the spreadsheet, find if it has a combined sewer overflow system or a sanitary sewer overflow system. So this is where you find basically what a definition of that is. You can see there's special requirements in the Great Lakes Basin, because the Great Lakes Basin is more there are some international compacts in the Great Lakes Basin about trying to protect the quality of water in the Great Lakes. Anyway, so combined sewer overflows, of which Kansas City is an example of a city with combined sewer overflow programs. So they have a section on their website dedicated to the overflow control program. And that is because they had to sign a consent decree with the Environmental Protection Agency. There's quite a massive amount of money required to fix a problem, like when your stormwater and your sanitary water combine and overflow. You get quite a mess releasing out of untreated water, releasing out into streams and rivers. So here's the webpage, reducing and preventing overflows from Kansas City's sewer systems creates a cleaner, healthier environment, but required a consent decree, which is a form of compliance requirement from the EPA to encourage the city to make these kinds of investments versus other kinds of investments. So they, as part of that agreement, the city has agreed to invest a certain amount in a smart sewer infrastructure, and has undertaken a certain number of compliance activities. Like if you go and read Keep Out the Rain, that's a program to make sure that people within the cities are not hooking their stormwater directly up into the sewer system, which it can be a problem in big towns or small towns. People do. This is, I think, an example of a tragedy of the commons kind of problems, where people will say, well, you know, at least I don't have my, you know, my eaves trough running into my yard and making a mess. I'll just hook it up into the sewer. But it does just, it's very costly to infrastructure, to sewage treatment, it overwhelms the system. So anyway, just a simple compliance problem like that for a jurisdiction the size of Kansas City is part of this program. The other part that's kind of interesting in this is that Kansas is also just trying to limit the flow of stormwater into its stormwater system through green infrastructure measures. So in the case of stormwater, green infrastructure measures involve using soft surfaces instead of hard surfaces. In street areas, it involves putting in swales or drainage swales as the water flows off the streets. It can be slowed down and possibly soaked into the soil to feed plants along the highways, again, to slow the, otherwise, if you have a hard surface infrastructure, you have a influx of stormwater that overwhelms the system. If you can put in some green infrastructure, some swales and some soft surfaces, some pervious surfaces, then you can slow that stormwater loading. One of the things that I thought I would look into a little bit, many of you are in locations that are forecast from your climate unit section to have higher rainfall intensity and duration, which is going to make stormwater, it already is overwhelming stormwater utilities, as well as, whether they're combined sewer or not, it overwhelms the stormwater, floods the streets. Let me think, I think it was Priscilla was going through that in Nashville the other day. So where is your state and municipality with responding to those kinds of changes in rainfall event? How is anyone making the link between those climate changes and the design standards we should be putting in place? So I delved into this just a little bit to see what I could find, and I'm not sure how useful it is to you guys at this stage. I think it's more useful for you at the inventory stage to say the stormwater is an increasing problem, unless you find something that says we are trying to adapt the stormwater system to the new reality. Because what I found when I just sort of dug into it a little bit, which I haven't done for a while, so initially there is stormwater permitting for municipalities. This has been around for a while. This pamphlet from the Iowa Department of Natural Resources it's the same pamphlet as it was 10 years ago. So basically, cities in these various metro areas are required to reduce non-point source pollution. So they're trying to, what's the connection there? When rainwater comes, if it's of a certain intensity and duration, it picks up pollutants as well as sediment and shoots them off into the receiving waters. It does that. The more hard surfaces and the more pollution there is laying on the ground, the worse the outcome will be for the streams. So there were non-point source pollution permits required for universities and urban areas, municipalities, under the Clean Water Act. So this is quite a while ago. It took a while to implement. But the main, for a place to have its permit, it has to have a method of ensuring that erosion and sediment are controlled on construction sites. You can see the 6 points. You should be improving your stormwater management. Have a system of inspecting your storm drain outlets. Make sure there's no illicit discharges coming out. You know, people aren't diverting waste streams into the stormwater streams, which is the other form of noncompliance. Educate residents. So you have an education program in place for residents so that they aren't pouring oil down the storm drain, and involve the public in implementing the city's plan for protecting water quality. So municipalities can mostly comply with this without making any major changes to their programs. So then I had a look to see, for example, how are the design standards for stormwater set. And so here are some Central Iowa, a chart of it's a rainfall chart, rainfall probability. So those 1 year, 2 year, 5 year, and 10 year are basically the probability based on past experience that level of duration and intensity will happen of rainfall over a period. So typically stormwater design, you know, when the engineer says, how much stormwater do we need to design this system for, they look in the design standards to set that. So this is what engineers are using now to build the infrastructure that's now being built. So this includes how much the pavement crowns and how big the ditches are and all those kinds of regular decisions. So this has been updated relatively recently, but the method is to look back at the last 100 years. So for example, for Central Iowa, there's a 10-year probability of getting 5 inches of rain in a 24-hour period down here in the circle, or a 5-year probability of having 4 inches of rain in a 24-hour period. This is the range of what people are going to be designing the stormwater infrastructure for. And any of those higher, like the 6 and 7 inch rains, are called 50-year and 100-year, and they're not part of the regular design standards. Where I think if you just looked at the past 10 years rather than the past 100 years, you would say that the probability of those is higher than 50 or 100 years, because they're happening in various places in Central Iowa at increased frequency. So this is one of the problems we have in the way that we're setting engineering standards, and that's why I don't know what to do with it for the inventory. So far, our urban design standards are set based on a 100-year history, but we're on this trend break from history where the historical rainfall data doesn't really predict future levels. The predictions predict future levels. So until those practices of standard setting catches up to that new reality, neighborhoods and infrastructure in the rainfall impacted areas will continue to be under designed for the actual frequency of stormwater events. So if you're in an area forecast to experience those rainfalls of higher intensity and duration, it sounds like rodent of unusual size. So have a look around to see what stormwater measures could the community be putting in place to handle that kind of, it's also, there's a level of unpredictability of future storms. Is there a low-lying area that, do you have enough low-lying areas that can be, regularly flooded without too much harm? What measures is the community already putting in place for those kinds of things? So again, this is a program that Des Moines has had for a while through the Parks Department. It's basically parks and schools. Put in systems of rain gardens, which are basically they're holding tank. It's like a sort of a large-scale plant pot, which suits the Des Moines area soils fairly well, because you can hold water in that kind of soil for quite a while, which is also why you need them. And then in terms of on an urban design scale, here we have this was done in part with some federal funding, a green infrastructure approach to an urban design area, the 6th Avenue or Riverbend part of the city, which goes from the Capitol down to the river, actually up and then down. So what I found when I was looking at the city of Des Moines is that they were using, this was a design principle that was being used in the city to accomplish some things which have multiple objectives. So if you look at this, at the streetscape, you can see the suggestion is to take the 66-foot right-of-way and instead of using it just for cars, to use it to increase the pedestrian walkability of this street, introduce some more permeable features, and also basically slow traffic, so that it's a livability, walkability kind of design concept altogether. So there's multiple objectives at the design level for this kind of thing, but it does include a stormwater component. And I think, okay, that's just a few of the products I wanted to go through. I'm going to stop sharing. So the other pieces that I had mentioned in the module or in the spreadsheet was that I would like you to have a look at the floodwater mapping for your community. Make sure that you get that. That has been relatively recently updated. Some of the cities, I noticed North Platte had a link directly to that site. Some of the larger scale cities, you can probably find a useful sort of map that at least points out some predicted problem areas for flooding. So basically what you're trying to do is just collect the information that there is. You're trying to understand the information that there is and put it together so you have a sense of where the city is with water. I just realized I didn't say anything about water supply outside of drought areas, but one of the questions about the vulnerability of your drinking water is your drinking water vulnerable to supply constraints in future? And a city like North Platte on the Platte River, I would want to look at that interstate compact about the Platte with Colorado. just see what I could find there, and see what direction I could get from the climate information. Like, is the river here, projected to change especially in its summer flow? Is drought something that this town is expected to be dealing with and may not be dealing with now? So that's in terms of your water supply. And you can always use the United States geological systems to find what there is concerning your aquifer, and it's the sustainability of use of the aquifer that your system's on. So hopefully all that is useful to you for this week's part of assignment 1. Thanks. Bye.